stone carving, worn by 12,000 years of time, reveals itself in the beam of a small flashlight. The intricate pattern, concentric circles surrounding what appears to be animals and human figures, has defied explanation for decades. Dr. Grace Venturi adjusts her glasses, the artificial light casting shadows that dance across the ancient relief as she carefully photographs each millimeter of the surface. This is Göbekli Tepe in southeastern Turkey, the world's oldest known megalithic structure, predating Stonehenge by 6,000 years and the Egyptian pyramids by 7,000. The patterns repeat, she whispers to her colleague, but not in ways we can interpret with traditional archaeological methods. What Grace does not yet realize is that these stone pillars, erected by people who had not yet discovered pottery or writing, contain patterns that would remain indecipherable until the development of advanced neural networks in the 21st century. The message hidden in these stones would ultimately rewrite our understanding of human history and our place in the cosmos. 3 days later, at Stanford University's Archaeological Computing Laboratory, an artificial intelligence system detects something no human eye had noticed in decades of study. The seemingly random arrangement of symbols at Göbekli Tepe follows mathematical relationships that should not have existed in the Stone Age. How could a pre-agricultural society encode advanced astronomical knowledge into stone? And why did they build these massive structures only to deliberately bury them after generations of use? What compelled them to leave a message that would take 12 millennia for humanity to decode? The answer would shake the foundations of archaeology, astronomy, and our understanding of human consciousness itself. The discovery of Göbekli Tepe in 1994 by German archaeologist Klaus Schmidt was already revolutionary. Located near the border of Syria in southeastern Turkey, the site initially appeared to be just another hill. Göbekli Tepe literally means potbelly hill in Turkish. But as excavations began, Schmidt realized he had stumbled upon something extraordinary. Massive T-shaped limestone pillars arranged in rings, decorated with intricate carvings of animals, abstract symbols, and occasionally, human figures. Carbon dating placed construction between 9500 and 800 BCE, a time when humans were supposed to be simple hunter-gatherers, not builders of complex monuments. This challenged the fundamental narrative of human civilization, that agriculture came first, then permanent settlements, then monumental architecture. Göbekli Tepe reversed this sequence, suggesting that complex religious or astronomical imperatives drove humans to settle down and develop agriculture to support the workers needed for such massive construction projects. The conventional timeline was wrong, explains Dr. Charlotte Garrison, head of computational archaeology at MIT. The site predates writing by 6,000 years. The people who built it had no metal tools, no pottery, no domesticated animals except dogs. Yet they quarried, carved, and erected stone pillars weighing up to 20 tons. For decades, the meaning of the site remained elusive. Archaeologists could identify the animals carved on the pillars: foxes, lions, boars, snakes, scorpions, and birds, but could not decipher why they were arranged in particular patterns or what message the builders might have intended to convey. In 2021, a multidisciplinary team led by Grace Venturi proposed something radical, applying the latest deep learning algorithms to analyze the spatial relationships and symbolic patterns at the site. The team included archaeologists, astronomers, linguists, and artificial intelligence specialists. Traditional archaeology has limits, Grace explained during her TED Talk that same year. We interpret ancient sites through our modern biases and fragmented knowledge. But what if we could create an objective system, an artificial intelligence with no preconceived notions about human history, to find patterns we might miss? The project, dubbed Stone Speak, received funding from the National Science Foundation and computational support from Google DeepMind. Their first challenge was creating a complete digital model of Göbekli Tepe, accurate down to the millimeter. For 3 years, teams used ground-penetrating radar, photogrammetry, and laser scanning to build the most detailed 3D model of an archaeological site ever created. By 2023, they had mapped not just the exposed portions of Göbekli Tepe, only about 5% of the site has been excavated, but also the sections still buried beneath centuries of deliberately placed backfill. The ancient builders had intentionally buried their creation after decades or centuries of use, preserving it for future discovery. The AI needed to be trained on something, but there was no comparable dataset of pre-writing symbolic systems. The team took an innovative approach, feeding the system information about every known ancient writing system, astronomical calendar, and symbolic communication method from cultures worldwide. We were not expecting immediate results, Dr. Gabriel Vassallo, the team's AI ethicist, admitted. This was a moonshot. We were asking a machine to decipher communications from people who lived before writing existed, created in a symbolic language no modern human understands. Then came the question that would open the door to discovery. What if the arrangement of the pillars themselves was part of the message? On a brisk November morning in 2024, Grace stared at her computer screen, coffee going cold beside her keyboard. The first analysis results from the AI system, nicknamed KEAT, for knowledge extraction from temporal encodings, had arrived. "This cannot be right," she muttered, rubbing her eyes. The screen displayed a series of overlapping geometric patterns extracted from the arrangement of pillars, animal carvings, and abstract symbols. KEAT had identified statistical regularities that appeared deliberate rather than random, patterns with astronomical significance. "Charlotte, are you seeing this?" Grace called to her colleague. Dr. Charlotte Garrison leaned over Grace's shoulder, her brow furrowing as she studied the screen. "Is that what I think it is?" The AI had detected alignments between the major pillars and specific celestial events that would have been visible from Göbekli Tepe 12,000 years ago. More remarkably, the statistical arrangement of symbols suggested knowledge of celestial cycles that should have been impossible for Stone Age humans to track without sophisticated instruments. "The system is highlighting the precession of the equinoxes," Charlotte whispered. "That's a 25,920-year cycle. How could they possibly know about that?" The precession of Earth's axis causes the position of stars to shift gradually over thousands of years. Detecting this pattern requires multigenerational observations and record-keeping. Modern astronomy only confirmed the exact duration of this cycle in the 20th century. Grace shook her head. "We need to run more tests. This could be a false pattern. The AI might be seeing connections that are not there." For the next 3 months, the team worked tirelessly to verify the findings. They refined the algorithm, challenged the results with null hypotheses, and consulted with skeptical colleagues. Each test strengthened rather than weakened the original conclusions. The AI had identified not just knowledge of precession, but also precise tracking of solar and lunar cycles, including eclipse predictions. The statistical probability of these alignments occurring by chance was astronomically low, less than 1 in a billion. "We need to present this carefully," Gabriel warned during a team meeting. "The archaeological community will be highly skeptical. Claims about advanced ancient knowledge have a troubled history tied to pseudoscience." Charlotte nodded. "We will present only what we can prove through the data. No speculation about how they acquired this knowledge or why." The team published their initial findings in Nature in early 2025. The paper, titled Computational Detection of Astronomical Knowledge Encoded in Pre-Neolithic Monumental Architecture, triggered immediate controversy. Many archaeologists dismissed the findings as algorithmic pareidolia, seeing patterns where none exist. The ancient builders of Göbekli Tepe were sophisticated, but attributing modern astronomical knowledge to them is a bridge too far, wrote Dr. Margaret Hodges, a prominent archaeological skeptic, in her response. But the evidence was difficult to dismiss entirely. Independent researchers began applying similar computational approaches to other ancient sites: Nabta Playa in Egypt, Chanquillo in Peru, stone circles in Europe, finding corresponding patterns that suggested a widespread astronomical knowledge system far more advanced than previously believed. 6 months after the publication, something unexpected happened. KEAT, continuously refining its analysis with new data, detected something the team had not programmed it to find: linguistic patterns. The symbols are not just astronomical markers, Grace realized with growing excitement. They form a proto-language. The room fell silent as the projection screen displayed a series of animal symbols from different pillars at Göbekli Tepe, arranged in a sequence that KEAT had determined was statistically significant. The team had gathered their international collaborators for an emergency meeting. "What you are looking at," Grace explained, pointing to the screen, is what Keat has identified as a syntactic structure. These symbols are not just decorative or representational, they appear to function like a primitive writing system, but one that operates on principles very different from later cuneiform or hieroglyphics. Dr. Elias Torres, a computational linguist who had joined the project, leaned forward. This challenges everything we know about the evolution of written language. The earliest known writing systems date to around 3200 BCE in Mesopotamia and Egypt. This would push that timeline back by 6,000 years. Not exactly writing as we understand it, Charlotte clarified. Keat suggests it is more like an encoded knowledge system, information preserved through symbolic relationships rather than phonetic or logographic representation. The AI had detected patterns suggesting the symbols functioned within a complex system of relationships. Animals were not just represented for their literal meaning but served as markers within a knowledge framework. A fox followed by a crane represented something different than a crane followed by a fox. The positioning, size, and orientation modified the meaning in systematic ways. It is like they created a memory system encoded in stone, Gabriel observed. Think of it as a prehistoric hard drive designed to preserve critical information. The question remained, what information was so important that an ancient people would devote generations to encoding it in stone? Keat's analysis suggested the information related to astronomical events, climate changes, and what appeared to be instructions or warnings. But the system could not yet fully translate the symbolic language. It could only detect its presence and some of its structural properties. Over the next year, the team refined their approach, feeding Keat additional data from newly excavated sections of Göbekli Tepe and similar sites across the region. The AI began to identify repeating patterns that appeared to function as sentence boundaries or conceptual units within the symbolic system. A breakthrough came when Dr. Raj Patel, an archaeoastronomer on the team, noticed something striking. When the symbolic patterns were mapped against astronomical data from 10,000 BCE, they aligned with a series of rare celestial events, including a period when both Encke's comet and the Taurid meteor shower would have been exceptionally visible. These people were recording specific celestial phenomena, Raj explained during a team meeting in late 2026. But why these particular events? What made them significant enough to encode in stone? Grace had been unusually quiet during the meeting, studying a separate dataset on her tablet. Finally, she looked up. I think I know, she said quietly. Keat has identified correlations between the symbolic patterns and paleoclimate data. The periods of intense astronomical activity they recorded coincide with abrupt climate shifts at the end of the Younger Dryas period. The Younger Dryas was a period of sudden cooling that affected Earth approximately 12,800 to 11,600 years ago, precisely when Göbekli Tepe was being constructed. The end of this period saw rapid warming and significant environmental changes that transformed the Middle East from a relatively lush region into one trending toward the arid conditions seen today. They were not just recording astronomical observations, Grace continued. They were documenting a connection between celestial events and climate change on Earth. They observed correlations between certain cometary appearances and meteorite showers and significant shifts in their environment. Charlotte's eyes widened. Are you suggesting they built Göbekli Tepe as a warning system? A way to preserve knowledge about astronomical events that preceded climate catastrophe? Not just a warning, Grace replied. Keat has identified what appears to be instructional sequences, symbolic combinations that suggest adaptive strategies for surviving environmental changes. The implication was staggering. Göbekli Tepe might have been created as a knowledge repository designed to help future generations navigate climate changes that the builders had learned were cyclical and predictable through astronomical observations. This would explain why they invested such enormous resources in the construction, Gabriel noted. They were creating a survival manual for humanity, encoded in the only medium they knew would last, stone. As the team processed this revelation, a notification appeared on Grace's screen. Keat had completed another analysis, this one comparing the symbolic patterns at Göbekli Tepe with proto-writing symbols from much later cultures across multiple continents. There are statistical similarities, Grace announced, scanning the results. Between the Göbekli Tepe symbols and early writing systems from Mesopotamia, the Indus Valley, and even prehistoric Europe and China, different enough to not be immediately recognizable as connected, but sharing structural properties that suggest influence. Are you saying Göbekli Tepe might be the origin point of human writing systems? Charlotte asked. Not necessarily the origin, Grace clarified, but possibly part of a knowledge transmission network that influenced later developments across multiple regions. The question is, how was this knowledge preserved and transmitted across thousands of years and thousands of miles? The team's findings, published in a series of papers throughout 2027, transformed archaeological discourse. The revelation that Göbekli Tepe contained an encoded knowledge system focused on astronomical climate correlations generated both excitement and skepticism in equal measure. Critics argued that the AI was finding patterns in noise, a technological version of seeing faces in clouds. Supporters pointed to the statistical robustness of the findings and the growing body of corroborating evidence from other ancient sites. What no one could deny was that something extraordinary had happened at Göbekli Tepe. Hunter-gatherers had somehow organized themselves to quarry, transport, carve, and erect massive stone monuments containing sophisticated astronomical alignments and symbolic communications, all without the supposed prerequisites of civilization like agriculture, metallurgy, or writing. In early 2028, a new phase of the project began. If Göbekli Tepe contained encoded knowledge about celestial-terrestrial relationships, could this information still have scientific value today? The team expanded to include climate scientists, astrophysicists, and experts in ancient technologies. Dr. Maya Hiroshi, a paleoclimatologist from the University of Tokyo, joined the project to examine whether the astronomical climate correlations recorded at Göbekli Tepe aligned with modern scientific understanding. What we are finding is remarkable, Maya explained during a presentation at the American Association for the Advancement of Science annual meeting. The symbolic sequences that Keat has identified as climate-related correlate strongly with ice core and sediment data showing abrupt climate changes. These ancient people were recording real phenomena, not superstitions or coincidences. The presentation included a striking visualization, a timeline showing the appearance of specific comets and meteor showers alongside sudden temperature shifts, as recorded in Greenland ice cores and lake sediments from the Middle East. The correlations were not perfect, but they were statistically significant. We are not suggesting that celestial events caused climate change in a direct, causal fashion, Maya emphasized. But there appear to be correlations that these ancient observers recognized, possibly related to cosmic dust loading in the upper atmosphere affecting solar radiation, or other mechanisms we are still investigating. Meanwhile, Grace and Charlotte focused on another mystery. If Göbekli Tepe was created to preserve critical knowledge, why was it deliberately buried after centuries of use? The answer emerged from an unexpected source. Keat, now analyzing subtle patterns in the backfill soil layers covering the monuments, detected evidence of organized, ritualistic burying. Not a single event, but a careful process conducted over generations. They did not abandon Göbekli Tepe, Charlotte explained to a packed auditorium at Oxford University. They preserved it. The careful burial protected the stone carvings from erosion and defacement. It was not an ending but an archiving, like placing a valuable document in a time capsule. Gabriel, who had been studying the spiritual dimensions of knowledge transmission in ancient societies, proposed a theory. Göbekli Tepe may have served its immediate purpose of knowledge transmission to surrounding communities. Once that knowledge had been sufficiently distributed into oral traditions, material culture, and possibly early proto-writing systems, the physical site was ceremonially archived, protected for rediscovery when that knowledge might be needed again. The most provocative question remained unanswered. How did a pre-agricultural society develop the astronomical knowledge encoded at Göbekli Tepe? The precision of their observations would have required centuries, if not millennia, of systematic sky-watching and record-keeping. Dr. Leo Whitman, an expert in archaeoastronomy, proposed what he called the deep history hypothesis. We have assumed that complex intellectual traditions require writing to be preserved across generations, Leo explained. But what if some ancient societies developed sophisticated oral transmission methods capable of preserving precise observations over thousands of years? Australian Aboriginal astronomical knowledge demonstrably preserved information about slowly changing star positions over 10,000 years without writing. Perhaps the builders of Göbekli Tepe were part of an intellectual tradition with roots extending deep into the Paleolithic. This hypothesis found support in recent genetic studies showing that human cognitive capabilities had been essentially modern for at least 100,000 years, far longer than the existence of writing or even agriculture. Anatomically and neurologically modern humans had tens of thousands of years to observe, record, and transmit knowledge before leaving any archaeological evidence we would recognize as civilization. By mid-2028, Keat had made another significant breakthrough. The AI system had identified what appeared to be numerical notations embedded within the symbolic patterns, a prehistoric mathematical system that tracked astronomical cycles with remarkable precision. They were not just recording observations, Grace announced during a press conference that made international headlines. They were predicting future celestial events based on recognized cycles. This was a predictive scientific system, not just a historical record. The implications of Grace's announcement rippled through scientific communities worldwide. If the builders of Göbekli Tepe possessed predictive astronomical knowledge, the timeline of scientific thinking needed serious revision. A mathematical analysis of the patterns identified by Keat revealed knowledge of prime numbers, Fibonacci sequences, and geometric relationships that would not be rediscovered in written mathematical traditions for thousands of years. We are not suggesting they had advanced mathematics in the modern sense, Dr. Vassallo clarified in a follow-up statement. But they clearly recognized numerical patterns in nature and celestial cycles, and encoded these relationships in their monumental architecture and symbolism. As 2029 began, excavations at Göbekli Tepe accelerated, with new areas being carefully uncovered based on Keat's predictions about the most informational-rich sections of the site. Each new discovery strengthened the AI's interpretive model, creating a positive feedback loop that rapidly expanded understanding of the site's purpose. One newly excavated pillar contained a sequence of animal symbols that Keat interpreted as a warning about a specific astronomical event, a period when Earth passes through the debris trail of a fragmented comet, creating meteor showers and potentially larger impacts. Dr. Elias Torres, working with astronomical data, made a startling discovery. The symbolic sequence appears to describe a recurring 2,800-year cycle when Earth intersects with a specific cometary debris field. According to calculations, we are approaching such an intersection in the next few decades. This revelation caught the attention of NASA and other space agencies, which began correlating the ancient predictions with modern observations of near-Earth objects. Surprisingly, several recently discovered asteroid clusters matched the orbital parameters suggested by the Göbekli Tepe symbolism. We are not saying that these ancient people had telescopes or spacecraft, Charlotte emphasized in an interview with Scientific American, but they were meticulous observers who recognized patterns over very long time frames. Patterns that our technology-assisted but short attention span civilization might have overlooked without their guidance. The scientific community remained divided. Some researchers embraced the findings, seeing them as evidence of the untapped intellectual capabilities of prehistoric humans. Others maintained skepticism, arguing that Keat was essentially creating patterns and meanings that the original builders never intended. Grace acknowledged the legitimate concerns about overinterpretation but pointed to the growing body of correlating evidence. When multiple lines of inquiry, archaeological, astronomical, mathematical, and climatological, all point to the same conclusion, we must consider the possibility that we have been underestimating our ancestors. In late 2029, the project entered a new phase when Keat began comparing the symbolic patterns at Göbekli Tepe with documented flood myths and climate catastrophe stories from cultures worldwide. The correlations are remarkable, Charlotte noted during a presentation at the World Archaeological Congress. Specific symbolic sequences at Göbekli Tepe match narrative elements found in flood myths across disparate cultures, from Mesopotamia to China, from the Americas to Australia. The analysis suggested that many of humanity's oldest stories, previously dismissed as mere myths, might contain encoded information about real climate events and astronomical phenomena. transmitted across vast distances and time periods. Gabriel, who had been studying the psychological aspects of knowledge transmission, proposed a theory. Humans evolved to remember information packaged as narratives much more effectively than abstract data. The builders of Göbekli Tepe may have encoded their scientific knowledge in proto-mythic formats, using animal symbols and narrative sequences, precisely because they understood this was the most effective way to ensure transmission across generations. As 2030 approached, the team made their most significant discovery yet. Keat, now analyzing subtle variations in carving depths across multiple pillars, detected what appeared to be intentional acoustic properties, patterns that would create specific sound resonances when the stone was struck or when wind passed through the original structures. They encoded information not just visually but acoustically, Grace explained, her voice trembling slightly with excitement. Specific pillars appear designed to resonate at frequencies corresponding to the astronomical cycles they track. It was a multisensory information storage system. Dr. Mei Zhang, an acoustical engineer who joined the project, confirmed this hypothesis through physical testing of the stone pillars. The T-shaped pillars resonate at specific frequencies when struck. Different pillars produce different tones, creating what amounts to a stone musical instrument encoding numerical relationships. This discovery connected Göbekli Tepe to acoustic properties found at other ancient sites worldwide, from the echo chambers of Newgrange in Ireland to the sound corridors of Chavín de Huántar in Peru. What had seemed like isolated curiosities now appeared as components of a sophisticated knowledge transmission system that spanned continents and millennia. The question remained, why would ancient people invest such enormous resources in preserving and transmitting this specific knowledge? In the summer of 2030, as the research team gathered for their annual symposium in Istanbul, Grace presented a comprehensive theory that tied together the various threads of their discoveries. Göbekli Tepe was not simply a temple or observatory, she began, addressing colleagues from dozens of countries. It was a message, one designed to survive catastrophic cultural collapse and transmit crucial knowledge to whoever might rediscover it in the future. That future society is us. The Great Hall fell silent as Grace continued, displaying a timeline on the screen behind her. Approximately 12,800 years ago, Earth experienced what we now call the Younger Dryas impact event, a period when fragments of a disintegrating comet struck or airburst over multiple continents, triggering abrupt climate cooling. This event coincides with mass extinctions of megafauna and disruption of human cultures worldwide. Evidence for this event had been mounting over the past decade: platinum dust deposits in ice cores, nanodiamonds formed under extreme pressure, and widespread charcoal layers, all dating to the same period. The people who eventually built Göbekli Tepe were survivors of this catastrophe, Grace continued. Through oral tradition and observation, they preserved knowledge of the relationship between celestial events and terrestrial consequences. They recognized that such events occur in cycles, some spanning thousands of years, and sought to warn future generations. Charlotte joined Grace at the podium, taking up the narrative. As the climate stabilized during the early Holocene, these people invested their surplus energy not in personal comfort or status objects, but in creating a knowledge repository designed to survive for millennia. They encoded information about astronomical cycles, climate relationships, and adaptation strategies into stone, using multiple redundant systems, visual symbols, mathematical relationships, astronomical alignments, and even acoustic properties. The presentation screen displayed a computer simulation showing how the symbolic information at Göbekli Tepe correlated with specific celestial cycles, climate shifts, and adaptation strategies. What makes this so remarkable, Charlotte emphasized, is that they were right. Modern scientific analysis confirms the astronomical cycles they identified and their correlation with climate patterns. They created an evidence-based warning system that has proven scientifically accurate 12,000 years later. Gabriel then addressed the psychological and spiritual dimensions. The builders knew that mere information might not survive cultural transmission over millennia. They embedded their knowledge in a sacred context, creating a site of such magnitude and mystery that it would command attention and preservation, even if its original purpose was forgotten. The deliberate burial of Göbekli Tepe now appeared as the final act in this transmission strategy. preserving the message until a time when it might be needed again and could be understood. Consider our moment in history, Grace concluded. We have rediscovered this message at precisely the time when humanity faces anthropogenic climate change and questions our relationship with astronomical threats like near-Earth objects. The builders of Göbekli Tepe experienced a climate catastrophe with potential astronomical triggers. They devoted generations to ensuring that future humanity, us, would receive their warning about recurring cycles and how to recognize the signs of impending changes. As the presentation ended, the audience sat in stunned silence before erupting into discussion. The theory was bold but supported by converging evidence from multiple scientific disciplines. If correct, it represented perhaps the longest-term communication ever achieved by humans. A message successfully transmitted across 500 generations. In the months that followed, Keat continued refining its interpretations, now incorporating data from newly identified sites similar to Göbekli Tepe across the region. The AI detected what appeared to be a network of knowledge transmission centers, each encoding complementary information about astronomical cycles, climate relationships, and adaptation strategies. Dr. Hiroshi, analyzing climate data correlated with the symbolic patterns, made another breakthrough. The symbolic sequences appear to predict not just a single type of climate event, but a spectrum of possibilities based on different astronomical scenarios. It was a prehistoric risk assessment system calculating variables we are only now beginning to understand with modern climate science. By early 2031, the scientific consensus had shifted. What had initially seemed like an outlandish interpretation was now supported by multiple lines of evidence. Göbekli Tepe represented a sophisticated knowledge transmission system created by people who had witnessed catastrophic climate change and developed the scientific foundation to predict its recurrence. This changes how we must think about human intellectual history, Grace explained during her keynote address at the National Academy of Sciences. Complex scientific thinking, observation, pattern recognition, prediction, and theory building predates writing by thousands of years. The cognitive capabilities we associate with modern science were present in humans who lived 12,000 years ago, just expressed through different mediums. The implications extended beyond archaeology. Climate scientists began incorporating the long-term astronomical cycles identified at Göbekli Tepe into their models, finding that they improved prediction accuracy for certain climate oscillations. Astronomers refined their tracking of near-Earth objects, paying special attention to the cometary debris fields highlighted in the ancient warning system. Perhaps most profoundly, the discovery forced a reevaluation of humanity's relationship with knowledge transmission across time. Modern civilization, with its emphasis on rapid innovation and digital information storage, had assumed superiority over all previous knowledge systems. Göbekli Tepe demonstrated that ancient societies had developed methods to transmit crucial information across timescales modern institutions rarely consider. The builders of Göbekli Tepe thought in terms of millennia, Charlotte observed in her widely shared TED Talk. They created a knowledge transmission system designed to function across 500 generations. By contrast, our longest-duration institutional planning rarely extends beyond a century, and our digital storage mediums become obsolete within decades. We may have much to learn from their long-term thinking. As 2032 began, the full message of Göbekli Tepe was becoming clear. Keat, now processing data from dozens of related sites across multiple continents, had reconstructed a comprehensive picture of the knowledge system encoded in stone. At its core was a profound understanding. Earth experiences cyclical changes driven by astronomical relationships, some unfolding over thousands of years. These cycles affect climate, resource availability, and the viability of different human adaptation strategies. By recognizing these patterns, human societies could prepare for changes rather than being blindsided by them. The message was not fatalistic, Grace explained during a United Nations address that captured global attention. It did not merely warn of inevitable disasters. It provided information about recognizing early indicators and adapting successfully. It was a message of resilience through knowledge. Gabriel, who had been studying the ethical implications of the discovery, noted a striking parallel. Like us, the builders of Göbekli Tepe lived during a period of rapid environmental change. Unlike us, They responded by creating institutions focused on knowledge preservation for the common good across vast timescales. Their monument represents one of the most altruistic acts in human history, dedicating enormous resources not for immediate benefit, but for the welfare of unknown future generations. The final piece of the puzzle emerged when Keat identified what appeared to be explicit instructions within the symbolic system, guidance for recognizing astronomical warning signs and implementing specific adaptation strategies. These included agricultural techniques suitable for different climate scenarios, water management approaches, and even social organization methods for maintaining knowledge through disruption. They were not just sending information, Charlotte realized. They were sending wisdom, tested approaches for maintaining social cohesion and knowledge continuity through periods of environmental stress. Dr. Zhang, who had continued studying the acoustic properties of the site, made another discovery. When the resonant frequencies of different pillars were converted into audible tones and played in the sequence indicated by the symbolic patterns, they created distinctive melodies. These musical sequences appear designed for memorization, she explained during a demonstration where she played the songs of Göbekli Tepe on reconstructed stone instruments. The patterns are mathematically structured to be memorable and emotionally engaging, perfect vehicles for oral transmission of knowledge. This revelation connected Göbekli Tepe to musical mnemonic traditions found in cultures worldwide, from the songlines of Aboriginal Australia to the epic poetic traditions of ancient Greece. What had seemed like separate cultural innovations now appeared as variations on a knowledge preservation system with roots extending back to the dawn of the Holocene. In June 2032, the research team published their comprehensive findings in a special issue of Science, accompanied by an interactive digital platform that allowed people worldwide to explore the message of Göbekli Tepe through multiple sensory dimensions: visual, mathematical, astronomical, and acoustic. The public response was overwhelming. In a world grappling with climate change, political polarization, and technological disruption, the message from the distant past resonated deeply. Here was evidence that humans had faced existential challenges before and had responded not with short-term self-interest but with multigenerational commitment to knowledge preservation for the common good. Perhaps the most important aspect of the message, Grace noted in her concluding remarks at the World Humanitarian Summit, is not the specific information it contains, but the fact that it was sent at all. 12,000 years ago, people who had witnessed environmental catastrophe chose to invest their limited resources in helping unknown future generations navigate similar challenges. They believed in humanity's future enough to speak to it across a chasm of 500 generations. The discovery sparked a global conversation about intergenerational ethics and knowledge preservation. If prehistoric people could create information systems designed to last millennia, what responsibility did modern civilization have to future generations? How could crucial knowledge be preserved through potential disruptions in digital infrastructure or social institutions? Inspired by Göbekli Tepe, international organizations began developing deep-time knowledge preservation projects, creating multiple redundant systems for transmitting crucial scientific, ecological, and cultural information across centuries and millennia, regardless of technological or institutional continuity. As Charlotte observed in the conclusion of her best-selling book, The 12,000-Year Message, the builders of Göbekli Tepe did not have our technology, but they understood something we have often forgotten, that human wisdom accumulates across generations and requires intentional preservation. They created perhaps the most successful time capsule in history, a message that survived 500 generations to reach us at precisely the moment when we needed its guidance. In the autumn of 2033, as Grace stood once again among the ancient pillars of Göbekli Tepe, she reflected on the journey of discovery. What had begun as an archaeological puzzle had become a profound message across time, one that was now reshaping humanity's relationship with its past and future. The site had been carefully preserved and protected, now recognized as a repository of invaluable knowledge rather than merely an archaeological curiosity. Researchers from diverse fields, climate science, astronomy, mathematics, linguistics, psychology, and more, continued to extract insights from the symbolic systems encoded in stone. Most remarkably, the warning system created at Göbekli Tepe was now being integrated into modern scientific frameworks. The astronomical cycles identified in the ancient knowledge system had improved models of climate variability, helping scientists distinguish between natural cycles and anthropogenic climate factors. The adaptation strategies encoded in the symbols, tested across millennia, were informing sustainable agriculture and water management practices in regions facing climate instability. The builders of this site would be astonished to know that their message not only survived but is being acted upon. Grace thought as she watched the setting sun cast long shadows across the ancient pillars. They reached across 12,000 years of time, and we heard them. The greatest lesson from Göbekli Tepe was not just the specific information it contained, but the demonstration that human knowledge could transcend individual lifetimes, cultures, languages, and even civilizational collapses. It offered a profound reminder that humanity is capable of thinking and acting on timescales far beyond the immediate, that we can be stewards of knowledge for generations yet unborn. As twilight deepened, Grace placed her hand on one of the ancient pillars, feeling the connection across time. The message of Göbekli Tepe had been waiting patiently in stone for 12,000 years until humanity developed the technological capabilities and scientific framework to comprehend it. An artificial intelligence system that could detect patterns invisible to human perception and integrate knowledge across multiple disciplines. In the end, the most profound realization was this: human minds separated by 12 millennia had successfully communicated about matters of existential importance. Through stone and symbol, through mathematics and astronomy, through music and myth, the builders of Göbekli Tepe had reached across time to share hard-won wisdom about survival and resilience in the face of environmental change. And we, their distant descendants, had finally heard their message. Across 12,000 years and 500 generations, humanity's ancient scientists spoke to us through patterns inscribed in stone, revealing that we have always possessed the capacity to understand our place in cosmic cycles and the wisdom to preserve knowledge not just for ourselves, but for the countless generations that will inherit our world.